This video is all on straight lines in 2 dimensions or 2D. First of all, just really quickly going to go over gradient and intercepts. So the gradient of a straight line is a measure of how steep the line is. The larger the number, the steeper the line. The gradient can be positive, negative or zero as shown in these 3 diagrams here. So if it's positive, it is a sloping upwards line like the first diagram. If the gradient is negative, it is a downward sloping line like the middle image. And if it is a zero gradient, then the line is horizontal because it is flat, so there is no steepness to it. The gradient, which is often denoted by the letter M, of a straight line through 2 points, x1, y1 and x2, y2 is found by using this equation here, m equals y2 minus y1 over x2 minus x1. So this equation finds the gradient of the line. The y-intercept is where the line cuts the y-axis, so where that line crosses the y-axis. The x-intercept is where the line crosses the x-axis. Parallel lines have the same gradient, and the last little bit, if 2 lines are perpendicular, then their gradients are the negative reciprocals of one another. So you've got a little explanation of that here. So m2, the gradient of the second line equals negative 1 over m1, the gradient of the first line, or when we multiply the 2 gradients together, we'll get negative 1 if the lines are perpendicular. Now we have 3 different forms of a linear equation that within the IB they use. We have the gradient intercept form, which is the most common that people know from earlier in high school, y equals mx plus c. M is a gradient and c is the y-intercept. We have the point gradient form, which is my personal favourite, and it is y minus y1 equals m bracket x minus x1. So you need the gradient and 1 point to substitute in. I prefer this form because you only need the gradient and 1 point, and then you can rearrange the other 2 forms really easily. Then the last one is a general form, which is ax plus by plus d equals 0, or can sometimes be seen as ax plus by equals d. Now in this form, a, b and d must be integers, and majority of the time the a value must also be positive. So we have a lot of examples just to show lots of different things with the different forms of linear equations and gradients, parallel, perpendicular lines, etc. So the first example, determine whether the following points lie on the line y equals 5x minus 2. So to work out if a point lies on the line, the easiest way is to sub in the x value into the equation, and if you get the given y value, then it must be on the line. So we have the point 3, 13. So if we're going to sub 3 into the x, it'll be 5 times 3 minus 2, which equals 15 minus 2. So then y equals 13. Does that match our point in the question? Yes, it does. Therefore, it's on the line. In B, we have 5, 3. So once again, we're going to sub 5 in. So it'll be 5 multiplied by 5 minus 2, which equals 25 minus 2, which equals 23. So y is 23 when x is 5, which does not equal the 3 we have in the points in the question. Therefore, it is not on the line. Example 2, determine the y-intercept and calculate the x-intercept of the line. Now this equation is in the form y equals mx plus c. And as we said before, in this equation, that c value is the y-intercept. So therefore, our y-intercept in this question, we can get straight from this form of the equation. It is just negative 10. Now to calculate the x-intercept, the x-intercept happens when y equals 0. So we can put 0 into the equation for y, so 0 equals 2x minus 10. Rearrange this to work out what x is, and that would be our x-intercept. So if we rearrange this, we'll end up with 5 equals x, and therefore the x-intercept happens when x equals 5. And the y-intercept, if it's not in that form, you can also find the y-intercept by making x equals 0. Example 3, a line passes through points A, which is negative 2, negative 5, and B, 1, 13. Find the equation of the line in the form y equals mx plus c. There's different ways you can do this. I'm going to do this the way that I prefer. which is using the point gradient form and then rearranging, means I am less likely to make a mistake. But the first thing we need to do in this equation is find the gradient, because we only know the points. So m equals, from the up above we had y2 minus y1 over x2 minus x1. Now with these equations, doesn't matter which is the 1 and the 2, as long as x1 and y1 are from the same bracket, that's all that matters. So I've just labelled them there quickly to sub them in. So y2, I have 13 minus y1, which is negative 5, all divided by x2, which is 1, minus x1, which is negative 2. Good thing to do is to check here that, as I'm circling these, they are the two coordinates, 1, 13, negative 2, negative 5. They should be above and below each other in this equation. Good way just to double check you've used the right values in the right spots. Always be careful with negatives too when doing this. So we have 13 minus 5, which is the same as 13 plus 5, so 18, over 1 minus 2, which is the same as 1 plus 2, which is 3, and 18 divided by 3 is 6. So our gradient is 6. Now to find the form y equals mx plus c. I will show you two different ways you can do this. It's up to you, whichever one you prefer. I'm going to do my preferred method first, which is actually to put it into the form of y minus y1 equals x minus x1. Now when you're doing this, even though it's y1 and x1, you could sum in either point and you will get the same answer. It doesn't matter. I generally look for the one that's going to be the easiest. Now for me, I'm actually going to use the x2, y2 because there's no negatives involved and I don't like negatives. So we'll have y minus the y value, which is 13 in point 2, equals our gradient, which is 6, open bracket, and x minus the x value from the same bracket, which was 1. Then I'm going to expand my brackets, so I'll get 6x minus 6, and then just rearrange, add the 13 to both sides, and I'll get y equals 6x minus 6 plus 13 is plus 7. Now I'll also show you here, if I was to sub in the other point, so y minus negative 5 equals 6 and x minus 2. So if I subbed in the other point I was given, I just want to do this to show that you would still get the same answer. And you see we've expanded the bracket there. Now if I minus 5 from both sides, I'm still going to end up with 6x plus 7. So you can see there, it doesn't matter which point you sub in, you're still going to get the same equation. Now the last way you could do this is to start off with the form y equals mx plus c. Sub in 1 point again and the gradient. So I'm going to use the easiest point, which is the b, because there's no negatives. 13 equals 6 multiplied by the 1, the x coordinate plus c, which means 13 equals 6 plus c, so 7 equals c, and then I can sub that back in. Now the reason I don't like doing it this way is that often people forget to, once they've found c, to sub it all back into the equation, and then they can lose a final answer mark because the final answer wants the equation, and often people would just find c and then leave it. Example 4, a straight line has equation y equals 2/3 x minus 7. Rearrange this equation into ax plus by plus c equals 0. Now with this question, the main issue is the fraction, because remember in our general form of ax plus by plus c equals 0, a, b and c have to be integers, so we can't have any fractions. Me personally in this situation, I like to get rid of the fraction first. Now here, our fraction is divided by 3. So to get rid of divide by 3, we have to multiply by 3. But we have to multiply everything in this equation by 3. So we'll multiply the y by 3. 2/3 divided by 3 means the 3 just cancels out, so we end up with 2x, but we also need to multiply the 7 by 3, so we have to multiply everything by 3. Now I've got everything as integers, I can rearrange this, so it equals 0, and then I have 2x, it'd be minus 3y, because we're going to pull the minus 3y, the 3y over, and then minus 21. And now I have it in that form. It doesn't matter that the equals is on the other side. They are the same thing, whether it's 0 equals or 2x minus 3y minus 21 equals 0. They're the same thing. Example 5, a straight line has equation 15x minus 3y plus 4 equals 0. Find the y-intercept coordinates, the x-intercept coordinates, and the gradient of the line. So start with finding the y-intercept. Now, y-intercept happens when x equals 0. So we're going to have our equation 15x minus 3y plus 4 equals 0, which means then we'll have 15 times 0 minus 3y plus 4 equals 0, which will just leave us with minus 3y plus 4 equals 0, and then I can just rearrange this. So 4 equals 3y, divide the 3, and so y equals 4 over 3. And now it says the y-intercept coordinates, which means I need to leave my answer as coordinates. Remember, x equals 0 and y is 4 over 3. Now part B, we want to find the x-intercept coordinates. Now the x-intercept is when y equals 0. So with our equation, we just need to make y equals 0, which means we'll have 15x minus 3 times 0 plus 4, which will leave us with 15x plus 4 equals 0, and then we can rearrange. And so x equals negative 4 over 15. And it's once again says x-intercept coordinates, so we need to write our answer as coordinates. So it'd be negative 4 over 15, comma 0. Then the last one is we want to find the gradient of the line. Two options here. We can find the gradient using the y-intercept and the x-intercept because we've got 2 points. Or we could rearrange our equation into the form y equals mx plus c and find it that way. I have 2 points there, so I'm just going to use my formula m equals y2 minus y1 over x2 minus x1. Sub the points in. So I'm going to make that my one coordinates and the second one my 2 coordinates. Once again, doesn't matter which way around. So y2 is 0 minus y1, 4 over 3, divided by x2, negative 4 over 15 minus 0, which means we'll get negative 4 over 3 divided by negative 4 over 15. And then when we work that out, we get just 5. And I'll show you how you could do this by just rearranging the equation. I'm just going to come up here to do that. So we want to rearrange the equation to y equals mx plus c. So I would rearrange this to 5x plus 4 equals 3y. So the y becomes positive. Then divide everything by 3. And we'll get 5x plus 4 and 3 equals y. Then you can see there 5 for the gradient. And you can also see here then the c is our y-intercept and that 4 over 3 matches what we got in part A. Example 6, find the equation of the line that goes to the points P4, 8 and Q6, 12 in the form y minus y1 equals m bracket x minus x1. Transform the equation to the other 2 forms. Now I'll explain the reason why I really like this form y minus y1 equals m bracket x minus x1. Because in an exam, if they just said to you, find the equation of the line, and they don't tell you which form to use, you can use any of the 3 forms. And generally, that form, the y minus y1 form, is the quickest and the easiest to quickly put together and move on to the next question. It's giving you more time in an exam than the other 2 forms to put together, which is why it's my favourite. Now let's get on with this example. So we have 2 points, so first of all we need to find the gradient. So m equals, once again, x1 and y1, x2 and y2, make your choice. I'm just going to have the p's are the 1s and the q's are the 2s. Doesn't matter which way around, as I've said previously. So we'll have 12 minus 8 over 6 minus 4, which will equal 4 over 2, which just equals 2. So our gradient is 2. Now it wants it in the form y minus y1. So y minus, once again, pick either of the equations. I'll use the equation 1 this time. So y minus 8 equals our gradient, which is 2. And then x minus 4. So remember that 8 and 4 are our coordinates from the question. Now we want to transform this equation into the forms y equals mx plus c and ax plus by plus c equals 0. But let's transfer first to the y equals mx plus c. So I have to do y equals. So the first thing I would do in this situation would be to get rid of brackets because there's no brackets in that final answer, which will give us 2x minus 8. And we want to add the 8 to the other side, which means we just get y equals 2x. Then if we were going to go to the ax plus a by plus c form, once again there's no brackets, so I would expand the brackets first. So y minus 8 equals 2x minus 8. This time though, I want everything on the one side of the equation, and I always do like the x to be positive. First of all, get the y over to the other side, so it'll be 2x minus y minus 8. Then I'll add the 8 to both sides, so we end up with 2x minus y. Example 7, write the equation of the line perpendicular to 3x plus 2y minus 1 equals 0 that passes through the point minus 2, 5. With this, we want to find the equation, so we need to know the gradient. The easiest way to find the gradient is to rearrange this equation to y equals mx plus c. So we're starting with 3x plus 2y minus 1 equals 0. I want the y to be positive, so I'm going to keep the 2y on this side of the equation and get the x and the constant to the other side, so that'll be minus 3x plus 1. Then I want y on its own, so I'm going to divide everything by 2 to get rid of the 2 in front of the y. Now remember, everything has to be divided by 2, not just the x value. Now we've got this, we know our gradient is the value in front of the x. So our gradient of this line is negative 3 over 2. But we are wanting the equation of the perpendicular line, which means we need to find the negative reciprocal, which means the gradient of the perpendicular line. So to do this really quickly, what I do is flip the fraction, so that's 3 over 2, so it'll be 2 over 3. And I change the sign. Now because this one's negative, this one's going to end up being positive. That's the easiest way to work this out. So the gradient of the perpendicular line is 2/3. Now we want the equation that goes through the point negative 2, 5. So from here, we've got our gradient and we have our point. So we can just sub this into the equation of a line. Once again, use which one you like, but I'm going to use my favourite one, y minus the y value, which is 5, equals our gradient 2 over 3, and then x minus the x value, which is negative 2. Then I can just simplify this down to y minus 5 equals 2/3 x plus 2. That's why, once again, you can see why I prefer that equation, because it's really quickly done and dusted, no rearranging required. And so that is a line that is perpendicular to the original one. Example 8, find the point of intersection of y equals 3x plus 2 and y equals x plus 4. Point of intersection, many different ways to do this. By hand, the easiest way is to just make the equations equal each other. Because they are both y equals, we can then do 3x plus 2 must equal x plus 4. You can only do this if both equations are y equals. And then we just rearrange to find out what x is. So we'd have 2x plus 2 equals 4. And then 2x equals 2, just to rearrange it, and therefore x equals 1. So we know an x equals 1, that's the point of the intersection, but we also have to find the y value. So we can just sub x equals 1 into either of the original equations. So y would equal 1 plus 4, which equals 5. So the point of intersection would be when x is 1 and y is 5. You can also do this on your graphics calculator, and I will go and show you how you can do that now. So on your calculator, what you need to do is you want to go down to the graph button, which is this blue one down the bottom here. We're going to put our equation into this top line, which is 3x plus 2. Just press enter on your calculator and it will draw the line. Then press the tab button, which is up here if you look at the keypad above the control button, and we put in our next equation, which is x plus 4. Press enter. Now we want to find this point of intersection here. So to do that, you're going to go to menu, analyze graph and intersection. Comes up with these dotted lines. We want to just put it either side. Just click on the calculator before it or after it and scroll past. As soon as it finds an intersection, it's going to pop up there in yellow. So just click again, and you can see here it has found the intersection point of 1, 5, which is what we found when we did it by hand. Okay, now I've shown you how to do that on the calculator, and that is the end of this video.